In this video, we are going to learn how to factor a polynomial into all of its linear factors, which means is that we're going to also find all of the zeros of the polynomial function. So here I have the polynomial function written for you: x to the fourth minus 7x cubed plus 27x squared minus 47x plus 26. And then I have a rough sketch of what you see on your calculator if you graphed it on the typical view screen of minus 10 to 10 in the x direction and minus 10 to 10 in the y direction. And we're going to use this to help us locate a couple of zeros. I have taken the liberty to show you here where it actually crosses the x-axis is at 1, 0 and at 2, 0. And if you remember from our graphs of polynomials, if it crosses through a 0 to the other side, that means its multiplicity is odd. And if it just goes straight through, that means its multiplicity is 1. So our two zeros that we have here are 1, multiplicity 1, and 2, multiplicity 1. Since our polynomial is degree 4, we need to have 4 zeros, and we only have 2 of them. So in order to finish this up, we're going to have to do synthetic division on the 2 zeros that we have. And before I do that, remember that if 1 is a 0, that means that x minus 1 is a factor. 1 is the 0. And if 2 is the 0, that means that x minus 2 is a factor. And since it's degree 4, I've got 2 more factors to find. So to set up the synthetic division, I use all the coefficients and the constant term from the polynomial: 1, negative 7, 27, etc. And I'm going to use the 1 first. You could do the 2 first. It doesn't really matter which one. Just to recap on synthetic division, you bring the first number down. You multiply this number here by this number here and put that answer below the negative 7. Then we add the negative 7 and the 1. Then we do the same thing as we just did previously. We multiply this 1 here by now the negative 6, which is negative 6, and put it under the 27. Add those. Then I do 1 times 21. Put that under the negative 47, add those, the 1 times negative 26, which is negative 26, and add those. So that last number is your remainder, which is 0, and we knew that was going to happen. So now what that means is, underneath here, the 1, the negative 6, the 21, and the negative 26, this represents what's left over when you divide by x minus 1, which is x cubed minus 6x squared plus 21x minus 26, remainder 0. We're going to do the division one more time on the 0, 2, or the factor x minus 2, however you want to think of it. Again, you bring down the first number. I multiply the 2 by the 1, which is 2, put it under the negative 6, and add. The 2 times the negative 4, which is negative 8, put it under the 21, add. And then the 2 times the 13, put it under the negative 26, and add. So here's what all of this here tells me. I have x minus 1 as a factor. I have x minus 2 as a factor. That's what we got from the graph. And then what's left over is 1, negative 4, and 13. That means x squared minus 4x plus 13. Now to find the 2 remaining zeros, what I have to do is I have to take the x squared minus 4x plus 13 and see when it equals 0. That's what zeros mean. When do we get a y value of 0 or an x-intercept? Since there's no coefficient in front of the x squared and the x term is even, I'm going to use completing the square to find those 2 remaining zeros. You don't have to do this. You can use quadratic formula, or better yet, if it factors, obviously you would factor, but I know that this one won't. So half of the middle term squared is what goes here, so that would be 4, which means over here is also a 4. So now I have x minus 2 squared equals negative 9. This tells me my remaining two zeros are complex zeros. You have an imaginary portion to it, because if I square root this to solve for x using the square root method, I get x minus 2 equals, the square root of negative 9 is plus or minus 3i. And the reason it's plus or minus is because we are the ones that are square rooting. Move the 2 over, and you are finished. Your two remaining zeros are 2 plus 3i and 2 minus 3i. So with 2 plus 3i is a 0, that would give me the factor x minus 2 minus 3i. And with 2 minus 3i is a 0, that gives me x minus 2 plus 3i. That's the remaining, the fourth zero. So our zeros are 1, 2, 2 plus 3i, and 2 minus 3i. And our factors are x minus 1, x minus 2, x minus 2 minus 3i, and x minus 2 plus 3i.